Benvinguts, bienvenus, welcome. I declare this solemn academic ceremony open on this, the 9th of May 2019, during which Dr. Evert Baerends and Dr. Sovan will be awarded honorary doctorates and welcome to the Senate of the University of Girona. I ask Dr. Emili Garcia Bertou to accompany Dr. Sovan to this presidential table. Unfortunately, I have to say that Dr. Evert Baerends cannot be with us today for health reasons. The General Secretary of the University has the floor and will read the agreement by the Governing Council of this university conferring the honorary doctoral degrees to Dr. Baerends and Dr. Sovan.
Thanks, Rector. Good morning, ladies and gentlemen. The Governing Council of the University of Girona, in ordinary session number 4, 2017, held on 27th May 2017, unanimously adopted the following agreement. Agreement to confer honorary doctorates from the University of Girona on Dr. Evert Baerends and on Dr. Sovan.
Thank you, General Secretary. Now Dr. Miquel Solà, sponsor of Dr. Evert Baerends, has the floor. Okay.
Rector magnífic de la Universitat de Girona, presidenta del Consell Social de la Universitat de Girona, secretari general, excel·lentíssimes autoritats acadèmiques, polítiques i civils, professor doctor Sovan, professor doctor Emili Garcia Bertou, membres de la comunitat universitària, amigues, amics. És per mi un honor poder presentar avui, juntament amb el professor Marcel Suart, en aquesta solemne sessió d'investidura, els mèrits que reuneix el professor Evert Baerends per ser investit doctor Honoris Causa per la nostra universitat. Aquesta concessió, promoguda pel Departament de Química i amb l'adhesió de l'Institut de Química Computacional i Catàlisi, s'ha fet tot prenent en consideració els criteris que estableix la normativa de la nostra universitat i molt especialment els que es refereixen a les seves aportacions científiques i a la seva vinculació amb la nostra universitat. Per qüestions de salut, ja ho ha dit el rector, el professor Evert Baerends no ens pot acompanyar avui en aquest acte. Des d'aquí li desitgem una total i ràpida recuperació. Amb el professor Marcel Suart hem preparat aquesta presentació dels mèrits del professor Evert Baerends i hem decidit que un servidor llegirà aquesta laudatio i que el professor Marcel Suart llegirà el discurs d'acceptació que ha escrit el professor Evert Baerends amb motiu d'aquesta ocasió. En una primera part de la presentació em referiré als mèrits científics del professor Evert Baerends i en aquest cas ho faré en anglès per tal que el professor Evert Baerends ens pugui seguir. I estàs, diguéssim, en principi seguint l'acte per streaming i en una segona part comentaré la vinculació del professor Evert Baerends amb la Universitat de Girona i tornaré al català. Scientific merits. To summarize in few words, the scientific career of Professor Baerends is a very complex task, since his main contribution, beyond the tangible achievements, lies in his capacity to transmit to his collaborators his enthusiasm for the discovery and his perennial commitment to rigor and truth. Evert Baerends has put his life career at the service of science as a way of acquiring knowledge and also as an instrument of its diffusion to the new generations. And he has done it with passion, as a simple extension of his passion for life in all its facets. Evert Baerends is an emeritus professor of the Vrije Universiteit Amsterdam. He's one of the most prominent researchers in the field of theoretical and computational chemistry nowadays. He was born in 1945 in Vorst, Friesland, a region of the Netherlands with its own language, like Catalonia. He did his PhD in the Vrije Universiteit Amsterdam under the supervision of Professor Pieter Roos. During his PhD, he had to deal with transition metal complexes. He started to study computationally this type of complexes with the traditional Hartree-Fock method, but he rapidly realized that this method was not providing reliable results. At this time, physicists studied solid crystals containing metals using the X-alpha method, a method based on the density functional theory, DFT. So he decided to investigate whether a method based on DFT could be used in transition metal chemistry. It was a brave, somewhat quixotic decision, by the way, for a man who physically reminds the Quixote, since nobody used the DFT method in chemistry before, and consequently he had to program his own code to perform the simulations. Pragmatic and efficient numerical approaches were implemented by Baerends to generate his own Hartree-Fock later program, which later became the Amsterdam Molecule Code, and currently is used widely by many computational chemists as the Amsterdam Density Functional ADF program. The program stands out by unique features such as later orbitals and the pioneering use of precise numerical integration, density fitting, linear scaling, and parallelization techniques. Since the 70s, Professor Baerends and his collaborator, with a special mention to the late Professor Tom Ziegler, have been demonstrating the utility of DFT tools for computational chemistry studies. 20 years after his first DFT calculations, the Gaussian program incorporated the DFT methods. It was in the Gaussian 92 release of this program. Thanks to the Gaussian implementation, DFT methods became highly popular in the theoretical and computational chemistry community. Today, DFT has become the computational quantum mechanical modeling method most used in physics, chemistry, and material science to investigate the electronic structure of atoms, molecules, and condensed phases. In 1998, the Nobel Prize of Chemistry was awarded to Walter Kohn for his development of the density functional theory, and to John Anthony Popple for his development of computational methods in quantum chemistry. DFT reached this level of popularity thanks to the work of Professor Baerends and collaborators, who proved the utility of this method. Many of us consider that it would have been fair to have included Professor Baerends in the list of awardees in the 1998 Nobel Prize in Chemistry. We will briefly refer to other relevant works of Evert Baerends. The aforementioned ADF program was later complemented by the BAN DFT program, which extends the molecular treatment to periodic systems. Also in this field, Professor Baerends made significant contributions. He also focused his efforts to elucidate the connection between properties of the change correlation potential and that of the so-called change correlation Hall. In this way, he was able to improve the calculation of response properties and time-dependent density functional theory. He also explored the relation between density matrix and the change correlation Hall. The density matrix functionals, which are the basis of the density matrix functional theory, were developed further in later studies, opening a promising avenue to improve current DFT methods. Analysis of the chemical bonding and chemical interactions, a central aspect of chemistry, was carried out by him using Morokuma's energy decomposition analysis as implemented in ADF program. The treatment of relativistic effects on electronic structure was also mastered by Professor Baerends. He developed the efficient and widely used zero-order regular approximation, ZORA, which is very well suited for application with density functional theory. Finally, the Baerends group developed also a multi-level approach entirely based on DFT. He particularly contributed to the field of property calculations with the frozen density embedding for molecules in solvents for properties like UV spectra, electron paramagnetic resonance, hyperfine coupling constants, and circular decoy spectra. All these huge scientific contributions have been gathered in more than 450 papers that have received more than 50,000 citations. His age index is 98. Among many distinctions, let us mention that he received in 2010 the prestigious Schrödinger Medal of the World Association for Theoretically Oriented Chemists, UdG, for his pioneering contributions to the development of computational density functional methods and his fundamental contributions to density functional theory and density matrix theory. Relacions amb l'UdG. El professor Baerends ha col·laborat amb molts dels químics teòrics més prestigiosos del món, però per nosaltres és un orgull poder destacar que el professor Baerends ha inspirat la recerca i ha contribuït decisivament a la formació i consolidació de moltes persones que actualment formen part del Departament de Química de l'Institut de Química Computacional i Catàlisi. La col·laboració que es va iniciar fa 25 anys, quan vaig visitar el laboratori del professor Baerends, ha influït decisivament durant la dècada dels anys 90 en la formació predoctoral i postdoctoral de varis membres de l'Institut de Química Computacional i Catàlisi i ha seguit fins a l'actualitat a través d'una col·laboració continuada entre els dos grups de recerca. El professor Baerends ha donat sempre suport als químics teòrics gironins, implicant-se en la seva formació i participant de manera molt destacada en el Girona Seminar de 2010 i de 2008 i de 2010, reunions bianuals organitzades per l'Institut. Ha contribuït de manera decisiva a millorar la qualitat de la recerca de l'Institut de Química Computacional i Catàlisi, del Departament de Química i de la Facultat de Ciències. De les visites de membres del grup de recerca del professor Baerends a Girona destaquem les que va fer en diverses ocasions el mateix professor Baerends, les de Matthias Wickelhaupt en incomptables ocasions, de Cèlia Fonseca Guerra, de Ruth Fischer i de Marcel Suar quan era postdoc en el grup de professor Baerends. Membres del nostre institut han visitat el grup de recerca del professor Baerends en diverses ocasions, com per exemple en Jordi Poeter com a doctorant i postdoc, en Pedro Salvador, en Marcel Suart, ja com a professor aquí a la Universitat de Girona, Sergei Viviochiskov, Sílvia Simón, Anna Dax, David Ugas, Laia Guillaumes, Juan Pablo Martínez i Abril Castro. I també un servidor que vaig realitzar una primera visita l'any 1994 que va marcar la meva carrera científica. La relació del professor Baerends amb la Universitat de Girona ha estat llarga i intensa i ha donat com a fruit més de 60 publicacions conjuntes, múltiples presentacions a congressos, així com la signatura de diversos convenis. El primer d'aquests convenis va ser signat l'11 de gener de 2012 i regulava la col·laboració entre les dues universitats en el camp de la química teòrica i computacional. Dos doctors, la Laia Guillaumes i Juan Pablo Martínez, ja han defensat la seva tesi cotutelada entre les Universitats de Girona i la Universitat Lliure d'Amsterdam, en base a aquest conveni. El professor Baerends té una projecció molt important, doncs, de mestratge sobre diversos professors i investigadors dels actuals Departament de Química i Institut de Química Computacional i Catàlisi. Val a dir que aquest mestratge s'ha estès a altres professors i investigadors d'altres universitats i centres de recerca catalans. Com a més destacades podem mencionar les col·laboracions del professor Baerends amb els professors Vicenç Baranxadell i Mariona Sodupe de la Universitat Autònoma de Barcelona, amb el professor Josep Maria Poblet de la Universitat Rovira i Virgili, que avui ens acompanya i al qual li agraeixo la seva presència aquí, i amb el professor Carles Bo de l'Institut Català d'Investigacions Químiques. Deixeu-me acabar amb un fragment del llibre Ideas sobre la complejidad del mundo del professor Jorge Wagensberg, recentment traspassat, físic català i professor de teoria dels processos irreversibles a la Facultat de Física de la Universitat de Barcelona, expert en museologia i primer director del Cosmocaixa. Sobre la simulació científica escriu Wagensberg: el panorama de la investigación científica de vanguardia se ha visto conmocionada por los simuladores. Los científicos conocen bien el valor de un resultado experimental o de un resultado teórico, pero ¿cuál es el valor de un resultado simulado? Hay dos extremos que interesa comentar. El primero se refiere a aquellas teorías que tienen poca oportunidad de llegar a ser contrastadas con la realidad. Son los científicos ultrateóricos, tanto que a veces, y no sin ironía, se les conoce como los científicos poeta. El drama aquí es una teoría sin experiencia. La simulación ayuda a estos científicos poeta porque ayuda a legitimar teorías. Ayuda menos que lo haría un experimento, de acuerdo, pero ayuda más que no tener nada. En este caso, la simulación no es experiencia, pero la sustituye en relación con la teoría. El otro extremo se refiere a observaciones o experimentos que se nos antojan incomprensibles por incomprensibles, esto es, cuando no puede encontrarse ninguna teoría que sea más compacta que la propia observación. Para muchos científicos, tales experimentos nada aportan en favor de la inteligibilidad de la realidad, no van más allá de la realidad, es decir, son solo una buena cocina. Al científico poeta se opone entonces, con similar problema, el científico cocinero. El drama ahora es el de una experiencia sin teoría. La simulación también sirve de socorro en este extremo. Un experimento que converja con cierta simulación tiene más valor científico que un experimento que no converja con nada en absoluto. Aquí la simulación no es teoría, pero hace la sustituye en el sentido de que confiere una cierta inteligibilidad a una cierta realidad. ¿En qué quedamos? ¿Es la simulación una especie de experiencia o una especie de teoría? La simulación no es teoría ni es experiencia, ni un mero útil de cálculo, sino una genuina forma de aproximación a la realidad que acaso esté revolucionando el mismísimo método científico. Com hem assenyalat al subratllar els mèrits científics del professor Baerends, aquest ha destacat tant en la vessant de químic poeta, desenvolupant una nova teoria no sempre confrontable amb els resultats experimentals i, per tant, necessitada de simulacions per ser legitimada, com en la vessant de químic cuiner, portant a terme simulacions que han permès fer més comprensibles realitats químiques altament complexes. Però anant més enllà i amb les seves simulacions ha aconseguit una comprensió profunda de l'enllaç químic. Un cop s'entén l'univers a nivell atòmic, la resta és senzill, va dir el professor Richard Feynman. Certament, les aportacions de Baerends ens han permès avançar en aquesta direcció i entendre millor el nostre univers a nivell atòmic i molecular. Baerends s'ha fet un lloc d'honor dins la potent escola holandesa de químics físics, entre els quals hi ha figures com Van der Waals, Premi Nobel de Física del 1910, Van Hoff, Premi Nobel de Química del 1901, Debye, Premi Nobel de Química del 1936, o Crutzen, Premi Nobel de Química del 1995. Isaac Newton va adaptar una frase atribuïda a Bernard de Chartres per dir: he pogut veure més lluny que ningú perquè he pujat a les espatlles de gegants. En el camp de la teoria del funcional de la densitat, Baerends ha estat un d'aquests gegants que ha permès a molts químics teòrics i computacionals, entre ells molts membres de l'Institut de Química Computacional i Catàlisi, veure-hi més lluny. Baerends ha estat una font d'inspiració permanent per a molts doctorants i postdocs que ha dirigit amb rigor i passió. Amb el seu mestratge, el professor Baerends ha contribuït decisivament a la formació d'investigadors que han fet aportacions molt rellevants en el camp de la química teòrica. Ha establert una xarxa de col·laboracions internacionals sòlida i, el que també és molt important, ho ha fet gràcies al seu esperit crític, un entusiasme sense fi, una capacitat de treball molt alta i una motivació per treballar en equip envejable. Tot plegat ha contribuït a fer avançar la frontera de la ciència i aixecar el nivell de la química a nivell de química teòrica europea i mundial. És, doncs, per moltes raons i certament per tot això, rector magnífic, que sol·licito que s'atorgui i es confereixi el grau de doctor honoris causa al professor Evert Baerends.
Moltes gràcies, Miquel, per les teves generoses i sentides paraules. Thank you, Dr. Solà, for your words of praise. As of this moment, Dr. Evert Baerends has joined other honorees in the Senate of the University of Girona. As I said before, unfortunately, for health reasons, he cannot be here with us today, but the medal and the diploma, symbols of the recognition accorded him by the University of Girona today, will be presented to him very soon. Thank you, Dr. Evert Baerends. Now, Dr. Marcel Swart, who on behalf of Dr. Evert Baerends will read his speech accepting his admission to the University of Girona. Marcel, the floor is yours.
So I will give this speech on behalf of Evert Baerends, but before I do that, I would like to give some personal words to himself, because he's watching this through the streaming. Beste Evert-Jan, het is jammer dat je er vandaag niet bij bent. En het is voor mij een hele eer om hier deze dankrede uit te spreken. Esteemed Rector Magnificus, President of the Board of Trustees of the University of Girona, esteemed authorities, professors, students and members of the university staff, ladies and gentlemen, it is a great honor for me to receive the doctorate Honoris Causa from your university, for several reasons. One of the reasons is the special place that Catalonia has held for me since a long time. I think contact started in the 90s when Dr. Michael Sola, now Professor Michael Sola, spent time as a postdoc in Amsterdam. I spent 3 summer periods as an Iberdrola Fellow at the Universitat Autónoma de Barcelona, being hosted by Professors Joan Bertran, Mariona Sedupe, and Vincenç Branchadel, renewing also contacts with the theoretical and computational chemistry group of the University of Girona at that time. The contacts have not been limited to the Universitat Autónoma de Barcelona or Girona. I remember memorable visits to Tarragona and to the University of Barcelona. I cannot record all contacts, but I should mention that since that time, a strong connection with the Netherlands has built up over the years, with many fruitful exchanges. Another reason to enjoy this award, apart from the personal honor it brings to me, is the tribute it constitutes to the field of science I am involved in and am representing today, namely chemistry. It is a truism that science in general, and chemistry and physics in particular, have shaped our modern world. Maybe I should include biology, and then in its wake also medical science. But let me note a bit chauvinistically that biochemistry has hugely impacted biology and medicine. It is not only the technical achievements of the natural sciences that have impacted our lives. Their influence is much broader and deeper. They shape our culture and our outlook on life. They are also a source of beauty. Chemistry offers the beauty of chemical structures. I just have to mention the DNA molecule with its intricate double helix structure. And chemistry is a creative art. It creates many new beautiful structures never before realized in nature. On this occasion, however, I want to stress the lesson that science teaches us about a mental outlook. Given that this award is in chemistry, in particular in theoretical chemistry, and then in the subfield of density functional theory, I think it is appropriate to highlight the role of open-mindedness, the lack of prejudice, the flexibility of mind to adopt new paradigms, even when not yet completely established. In science, any preconception runs the risk of being thoroughly demolished. It appears that all obvious conceptions in whatever field one is interested in are bound to be dispelled by further investigation. By way of example, before I focus on theoretical chemistry, let me remind you of a very well-known, but actually very esoteric problem that the most famous scientist ever has set himself. This most famous scientist is Einstein, you will agree. The question he struggled with is, can anything go faster than light? Isn't that an irritating question at the time that the highest speeds were achieved by trains running circa 100 kilometers per hour, compared to the speed of light, which goes at 300,000 kilometers a second? I'm afraid a grand application by Einstein would not have been rated high as usefulness for society. Now we all know that Einstein's results have revealed staggering insights in such fundamental issues as the nature of space and time. But also position determination with GPS needs Einstein's theory of relativity. The utterly useful and very widely employed GPS devices that serve as the everyday navigation equipment in our automobiles rely on the theory of relativity. GPS has also revolutionized navigation at sea. Sextants and celestial navigation are not even taught anymore at maritime schools. Often, the more fundamental insights are, the more revolutionary and useful they prove to be. The lesson is, never reject a notion or question offhand, however irritating or esoteric it may seem. Be open-minded and unprejudiced. Let me focus then on chemistry and to make a long story short, on my own field of the theory of chemical bonding and structure. Let me start with the picture of bonding by electron pairs as developed by Gilbert Lewis, shown here, which I think every high school student will remember from his chemistry classes. In the first decades of the 20th century, Lewis pictures chemical bonds as arising from electron pairs, and the remaining electrons pairing up in so-called lone pairs. This model rationalized a large number of known facts. In the first place, the predominance of compounds with an even number of electrons. In the second place, the explanation within this model of the valences of the elements when combined with the rule that an atom tries to collect 8 electrons, the octet rule. But of course, there's also something ridiculous in this theory. Why would negatively charged electrons, which according to electrostatics will repel each other, get together to form a bond? Moreover, just at the time Lewis was developing these ideas, the Bohr theory of the hydrogen atom, which pictures electrons as fast-moving particles circling the atomic nucleus, like planets are circling the sun, was astonishingly successful in predicting quantitatively the spectra of the hydrogen atom. In a sense, Bohr's model marks the beginning of the efforts that would lead, about a decade later, to quantum mechanics. Quantum mechanics is one of the 2 great theories of physics to emerge in the 20th century, and from the physics side there was only ridicule and contempt for Lewis's model. And not only from physics, also many physical chemists felt that Lewis's electron pair theory was too simplistic. The basis of electronic structure theory should rest firmly in the quantum theoretical treatment of the motions of the electrons. This may have cost Lewis the Nobel Prize. He is often referred to as the most famous and deserving chemist who never got the prize. But we should recognize that Lewis has had enormous impact in chemistry. His concepts were so useful and such an excellent basis for theorizing about bonding in molecules that even today every chemist knows what Lewis structures are. Much of his thinking, for instance his generalization of the concept of acidity and basicity to donation and acceptance of electron pairs, are now fully vindicated by quantum chemistry. Lewis is another example that we should be beware of hasty condemnation and be open-minded and unprejudiced. It has been Linus Pauling who has done an admirable job of tying in quantum mechanics with Lewis's ideas, even before computers were powerful enough to actually perform quantum mechanical calculations on the motion of the electrons. He realized that even without computation, one can give chemists a feeling for the relative importance of quantum mechanical effects by considering what he called resonance among various electronic structures. These contributions, also called valence bond structures, translate into simple pictures the quantum mechanical superposition principle. Many chemists who never studied quantum mechanics in any depth and would think of it as a rather esoteric physical theory, were, as a matter of fact, practicing quantum mechanical concepts in their daily thinking, in talking about the structures and reactivity of their compounds. I'm ashamed to admit that as a young theoretical chemist, I have made the error of ridiculing Lewis's and Pauling's models with their unphysical electron pairs, and the errors indicating how these pairs might hop around in order to create other contributing resonance structures. So modesty is something that has to be acquired. We should be open-minded and modest enough to keep in mind that what seems at first sight to be absurd and contrary to accepted wisdom may eventually turn out to contain a lot of truth. Lewis and Pauling created the paper and pencil method for judging bonding and structures of compounds. But when computers became sufficiently powerful, it became possible to actually carry out the complicated and time-consuming calculations that are necessary to solve the quantum mechanical equations with sufficient accuracy. Sufficient accuracy was denoted chemical accuracy, something like 0.1 kcal per mole in the energy. That would make it possible to actually do chemistry on the computer or in silico. This development started slowly in the 50s and then made great leaps in the subsequent decades, mostly through the astonishing improvements in computer technology. Expectations, in my opinion unrealistic, were very high that eventually, maybe even soon, reducing chemistry to computational science might become a reality. There was also a clear paradigm. Calculations should be done ab initio, that is, by solving the equations purely by mathematical and numerical methods, without empirical parameters. We may use the picture of Thomas Kuhn, who distinguished periods of normal science and scientific revolutions. In our case then, the paradigm was given. No scientific revolution would be needed. We could envisage periods of normal science where theoretical chemists would work hard on the given task of developing increasingly sophisticated and efficient techniques of solving the given equations. They would eventually reach the holy grail of chemical accuracy. As Kuhn describes, scientists usually enjoy such normal science. The goal is clear, it is easy to see who makes the smartest contribution to solving the set problem. All efforts can be directed toward developing methods to solve the given problem. No need to waste time and energy on debates about the underlying science or the goals to be reached. However, the downside is that the scientists no longer are so modest as to recognize that maybe the chosen path is not the right one, or at least not the only one. They may hate colleagues who will doubt the accepted paradigm, with a professional and sometimes even personal hatred. This is what happened when in the 70s and 80s a new paradigm was provided in our science by the advent of density functional theory. We give it the acronym DFT. This is not the place to go into any detail about this theory. Let me just note that it provided a great simplification of the equations to be solved. The big drawback was the absence of a simple, straightforward path to the exact solutions. In theory, DFT did afford exact solutions, but often, in theory, means an euphemism for not in practice. That is also to some extent the case with DFT, but not completely. It has not been made exact, by no means, but it is sufficiently accurate to be eminently useful. My career has entirely revolved around this particular approach. DFT has become thoroughly successful, but now maybe 90% of all quantum chemical calculations are DFT calculations. But the initial reception of DFT was utterly hostile. How did a small group of theoretical chemists dare to challenge the path forward that had been chosen by the very large majority of theoretical chemists, namely ab initio calculations? If I look back on my career, I like to divide it into two halves. The first 20 years, 70s and 80s, I was met as a DFT practitioner and developer with scorn and contempt. I remember a conference organized with two well-known professors in our field in the mid-80s, where I was invited as a speaker. But they were harassing me so much at that meeting that afterwards the students invited me to dinner, telling me how embarrassed they were by this treatment. That is an illustration of the danger that old and established scientists are in. They may get too much entrenched in the pet theories and methods and may start to considering anything else as an aberration. It is also a beautiful illustration that, fortunately, young people tend to be much more open-minded. That I am receiving this doctorate or Honoris Causa today, I consider a great honor for me personally. But at the same time, I think it is recognition of the importance of the scientific revolution that has led to the predominance of DFT in our field, in particular for large systems. But what I want to single out most is that, again, we see demonstrated that as scientists, we should never be rigid and prejudiced. We should be rigorous in our proofs and deductions, but that is a different matter. Things may always turn out to be just the opposite of what we think. Actually, they very often do. The ab initio approach looks so admirably clear and rigorous, while DFT was, and still is, far from straightforward, and indeed somewhat muddled. Many people do not fully understand it, and there is still much to be criticized. But it has provided an enormous boost to the application of quantum chemical methods in chemistry. When I started my scientific career, most of the chemistry professors at my university, and surely at other universities as well, would question any chemical relevance of the theoretical chemists, with the penchant for mathematics and physics and computer work. That attitude amongst experimental colleagues has totally disappeared. They now enjoy to have computational input to their work. That's almost 100% owing to DFT. So DFT is my last and telling example of the great virtue and even necessity in science to be open-minded and without prejudice. It gives me great joy and satisfaction that this award underlines how this principle can lead, as so often in history, to unexpected and important progress. Thank you for your attention.
Dr. Emily Garcia Bertou, sponsor of Dr. Sovan Lloc. The floor is now yours.
Rector magnífic, digníssimes autoritats, companys de la comunitat universitària. També parlaré sobretot en anglès perquè m'entenguin el professor Lloc i diversos acompanyants estrangers i al final resumiré breument algunes coses en català. It is an honor and a pleasure for me to summarize in this solemn academic session the merits of Professor Sovan Lloc in order to grant him an honorary doctorate by the University of Girona. This honorary doctorate was promoted by the Department of Environmental Science of this university. Sovan Lloc was born in 1952 in Cambodia. As you know, Cambodia is a country between Thailand and Vietnam in Southeast Asia. Cambodia is best known by the temple complex of Angkor Wat, which is a UNESCO World Heritage Site and was built by the Khmer Empire around the 12th century. Cambodia is also sadly known by the Cambodian genocide performed by the Khmer Rouge from 1975 until 1979, which killed more than 1.5 million people. Professor Lloc was fortunate to have obtained a Bachelor of Science the year before the genocide in 1974 at the University of Phnom Penh and had moved to France to pursue his studies. He obtained a Master's of Science in Hydrobiology at the University Paul Sabatier in Toulouse in 1975 and a PhD in Hydrobiology at the University Paul Sabatier under the supervision of Christian Levesque in 1978. His PhD thesis was on the biology and ecology of small cruciform fishes in Lake Chad, Africa. He was later an assistant professor at the University of Algiers in Algeria from 1979 to 1983, and assistant professor at the University of Magna in Morocco from 1983 to 1989. He afterwards joined the University Paul Sabatier, Toulouse III, with his wife Sitan Lloc, who is also an ecologist and is also present here. They did the rest of their scientific careers in Toulouse. Sovan Lloc is an exceptional class professor at the University of Toulouse, and he is now emeritus professor. The research of Professor Lloc has focused on community ecology of freshwater fish and ecological modeling. Within community ecology, he has helped to understand how environmental factors and human perturbations, such as climate change or reservoirs, affect inland fish or freshwater fish. Freshwater fish are expected to be much affected by climate change because of many factors. Climate change will affect water availability and the flow regime of rivers. Freshwater fish dispersal is generally emitted within river basins, and they cannot so easily adapt to climate change. And most freshwater organisms are ectothermic or cold-blooded, as is commonly known. And the ecological functioning of freshwater ecosystems depends markedly on temperature. Professor Lloc has co-authored several of the best papers that model the likely future effects of climate change on freshwater fish in Europe. He, with his colleagues, has shown that cold water species will have their habitat reduced and will disappear from many river reaches, whereas other species will shift their distribution, changing overall the structure of ecological communities. Professor Lloc has also published many papers on the current and future ecological effects of dams. Dams or reservoirs are very important to society because they provide water for human consumption, irrigation, or industries. They regulate floods and they generate electricity. However, damming also have huge environmental impacts. They completely alter the flow regime of rivers, the sediment and temperature regimes, their ecosystem functioning, their connectivity, the extent of floodplains, riparian ecosystems, and wetlands. They really change everything. Like our research group, Professor Lloc has shown that the small hydropower dams in the Pyrenees change the flow regime and abundance of brown trout. He has also shown that in some of the world's largest rivers, like the Mekong River in Asia, which rises in China and crosses Southeast Asia, dams disrupt natural seasonal river pulses, decrease species diversity, homogenize fish faunas, and favor generalist species. He has also led some large research projects in Tonle Sap Lake, which is the largest natural lake in Southeast Asia, and constitutes one of the world's largest fisheries, supporting the livelihood of millions of people. Tonle Sap Lake is a flood pulse silt system affected by fish overexploitation and dam construction in the Mekong River, where many hydropower reservoirs are being built or planned, like in many regions of the world, particularly in the tropics. The other main research topic of Professor Lloc is machine learning and the application of advanced modeling techniques to ecological data. His three most cited papers are three papers on the application of artificial neural networks published in the journal Ecological Modeling. In the words of Professor Lloc, artificial neural networks are techniques originating from artificial intelligence and that are intelligent thinking machines working in the same way as the animal brain. They learn from the experience in a way that no conventional computer can, and they can rapidly solve hard computational problems. In the 1990s, Professor Lloc pioneered the application of artificial neural networks in ecology, in a time where they were much more difficult to apply than now. Now, artificial neural networks are routinely applied in many topics, in speech or image recognition, in chemical or biomedical research. Professor Lloc has edited several books that deal with these modeling techniques, notably two entitled Artificial Neural Networks, Application to Ecology and Evolution, published in the year 2000, and Modeling Community Structure in Freshwater Ecosystems, published in 2005. Sovan Lloc has over 250 international publications that have received many thousand citations. But there are many other important aspects in a scientific career. Professor Lloc has taught all his career in Toulouse and in recent years many courses for free in his home country, Cambodia. He has advised many students and obtained funding and coordinated several European projects. He has also participated in university management, for instance, as director of a PhD school in Toulouse. We often forget that an academic career is much more than publications and many other aspects, such as teaching, supervision, coordination of research groups, university management, editorial work and peer review or outreach are equally important. In all these aspects, Professor Lloc has made many important contributions. However, perhaps a more decisive reason that motivated his nomination as a potential honoris causa was his leading work in many Erasmus Mundus and Erasmus Plus projects of the European Commission, some of which also had the University of Girona as a partner. Erasmus Mundus partnerships were cooperation and mobility programs between European and third country higher education institutions, mostly from developing countries, that included scholarships and fellowships for mobility. They have been replaced in recent years by Erasmus Plus actions. Professor Lloc has conceived, obtained funding, and participated in about 9 European Erasmus Mundus or Erasmus Plus projects, 5 of them involving the University of Girona. I was very fortunate to participate in 3 of them as a coordinator at UdG, Techno 2, and NESI. Thanks to this Techno 2, and NESI, led by Professor Lloc, Jean-Michel Vanino, and Georges Zissis, respectively, UdG received over €1 million that allowed to bring to Girona about 75 students and academics, mostly from Asia. About 28 Cambodians, 8 people from China, 5 from Laos, 5 from Vietnam, and 4 from Thailand, and a few others from Malaysia, Indonesia, and Mongolia, among others, came to UdG to pursue all kinds of studies or stays, from the undergraduate, master, doctoral, or postdoctoral level, or as a staff stay. We now have many Asian people who obtain the master's degree or the PhD degree at the University of Girona, and are now back in Cambodia or their home country to transfer their education or research skills to newer generations and to continue their relationship with UdG. Thanks to the NESI partnership, 16 UdG's researchers, some of which are here, visited New Zealand or Australia, and some new researchers from Korea, New Zealand, or Australia also stayed in Girona. I would like to take this opportunity to thank the many people from UdG that helped a lot in these partnerships, notably Raquel Solá, Laura Ripoll, and others from the External Relations Office, Patricia Eiskens, then at the Polytechnic School, and many academics such as Dr. Evert, Dr. Kim de Ciuran, and Dr. Gerard Aguat, among others. Although these partnerships implied a lot of work for me that is not necessarily valued in academia, they were really a milestone in my career that enriched my personal experience and were rewarding in terms of learning about new cultures, landscapes, and the humankind, and helping people. I know that they were enriching for many UdG peoples and particularly for the many Asian people involved. The Erasmus Mundus partnership were later on replaced with Erasmus Plus actions, and Dr. Elena Wask at UdG recently led one called UNICAM to implement a Master of Science in Sustainable Agriculture in Cambodia, and Professor Lloc is leading one called CONSIA to implement a master program in aquatic biodiversity and conservation and a PhD program in sustainable ecosystem management in Southeast Asia, with the participation also of UdG, coordinated by Dr. Anna Villa-Gispert. All these partnerships and actions were promoted and made a reality largely by Professor Lloc, and opened many doors of Asia for UdG. Cambodia is still one of the world's poorest countries, among 47 of the least developed countries according to the United Nations, and an important motivation of Professor Lloc's activity has been always to improve Cambodia's educational and research quality and to return to his home country what he obtained in France. He has certainly and unselfishly succeeded to do so, and at the same time benefited Girona and its university. I ara el breu resum en català. El professor Lloc ha publicat més de 250 treballs a revistes internacionals, sobretot en ecologia de comunitats de peixos continentals i en l'aplicació de tècniques noves d'anàlisi, com les xarxes neuronals artificials a les dades ecològiques. Però també té moltes altres contribucions tant o més importants, com millorar la recerca i el coneixement ambiental a països en desenvolupament, com Cambodja, el seu país d'origen. També ha promogut i en bona part liderat 9 projectes Erasmus Mundus i Erasmus Plus, en 5 dels quals ha participat la Universitat de Girona. Gràcies a aquests projectes, la UdG ha rebut més d'1 milió d'euros, amb els quals més de 75 estudiants o acadèmics asiàtics han vingut a la UdG per tal de fer estudis de grau, postgrau o recerca. I més de 16 investigadors de l'UdG han fet estades a Àsia, Austràlia o Nova Zelanda. Aquest doctorat honorífic també és oportú perquè el govern català va aprovar que el 2019 celebrem oficialment el centenari del naixement del professor Ramon Margalef, un altre ecòleg, i perquè cada any el dia 9 de maig, com avui, és la Diada d'Europa. Ramon Margalef és àmpliament considerat com l'ecòleg més influent que l'estat espanyol ha tingut. I un altre exemple, com el professor Lloc, que tot i que les publicacions internacionals són el producte principal d'investigació dels científics, hi ha altres aspectes encara més importants per ser molt influents, com per exemple els llibres, la supervisió d'estudiants, l'ensenyament universitari, la col·laboració internacional i la transferència de coneixement. Els professors Margalef i Lloc són també exemples que la investigació ambiental i ecològica és més important que mai en un món canviant i que té molts problemes ambientals i socials. Amb aquest doctorat Honoris Causa, el professor Lloc, la Universitat de Girona ajuda a celebrar el centenari del naixement del professor Ramon Margalef i ajuda a reconèixer la importància de la cooperació i l'educació universitària als països en desenvolupament, la col·laboració europea i internacional, la recerca ambiental i la conservació de la biodiversitat. És doncs per això, rector magnífic, que sol·licito que s'atorgui i es confereixi el grau de doctor Honoris Causa al senyor Sovan.
Dr. Sovan Lloc, I hereby confer upon you the degree of Doctor Honoris Causa of the University of Girona for having excelled in the ecology of inland fish species and in ecological modeling, and for having opened the door to UdG's involvement in Southeast Asia through various Erasmus Mundus and Erasmus Plus projects. As a symbol, I present you this honorary doctorate medal and this diploma, and I admit and incorporate you to the Senate of the University of Girona. Je suis aujourd'hui très heureux de vous accueillir comme un docteur honoris causa pour la Université de Girona et merci beaucoup pour toute votre contribution avec la Université de Girona. Merci. Ça, c'est la médaille. Encore une fois, merci beaucoup pour votre générosité. Merci beaucoup. on this occasion of admission to the Senate of the University of Girona of Dr. Sovan. Dr. Sovan, please, you have the floor.
Distinguished Rector of the University of Girona, distinguished academic, political, and civil authority, colleague from university community, dear student, ladies and gentlemen, I am honored to be in the Honoris Causa list of UdG, and I am very happy to be present in this solemn academic ceremony. Emily give you already a lot of story about me, okay? But first, I like to complete something, because as you can see me by my name, my physics. I live in Toulouse, in France, but I'm not the Gaulois, okay? So, my father, he was born, maybe talking about Cambodia, but my father born in China in 1916, and in 1940, in Europe, you are the Second War, but in China, it's terrible. In the great crisis, there are no food to eat, and the total insecurity. For instance, my grandfather was murdered at that time, and then his body never found, okay, up to now. And then my father, age 24, decided to migrate to Cambodia. And me, I was born in 1952 in Cambodia, the third of the ninth in the family. In 1974, like Emily talking to you, I left Cambodia to do PhD in Toulouse for 3 years, because I got the scholarship from the French government. When I finished my PhD in 1978, it was Khmer Rouge and Pol Pot regime in Cambodia. You know all of this. And I decided to did not return to the country, and up now I stay always in Toulouse. So when with my wife here present, we have 2 sons, born in 1977 and 1980. Both are aeronautical engineer, linked probably to our life in Toulouse. One son works now in Paris, but another one decided to leave France to Canada. In 2011, he has worked in Toulouse, but he don't like to stay. He decided to leave to Canada to have international experience. But he still stay in Canada, and last year he got Canadian citizenship. Now I have one son and one granddaughter born in Canada. So as you can see, we are really global citizens. I had the chance to be integrated in University Post-Sabatier Toulouse 3 as full professor, and it's an opportunity to me to set up aquatic research team, namely AquaEco, between the laboratory, namely evolution and biological diversity. AquaEco account now more than 10 researchers, permanent staff, including university professor, but also a researcher from Ciències, IRD, Institute for Research and Development, because the French system is very different, because the lab merging different organizations from university and research institution. My research focus, like Emily mentioned, especially to the change of biodiversity in the context of changing world, including climate change, including environmental changes. Biodiversity, such as species richness, that means the number of species living in the specific area, is strongly impacted by the modern life. So understanding the mechanism of biodiversity change is in the context of the changing world is very important. My research focus especially to the development of the efficiency statistical methods that can predict biodiversity change in space and time. I'm not a statistician, but we need that tool to do that. For example, I had used ANN, artificial neural networks, very early in year 1990, to predict fish species richness worldwide. Okay? At the global scale, fish diversity is different from one place to another place. For instance, there are 1,000 species of fish living in Amazon, but only 20 to 30 species living in Ebro. And many of them are exotic, that means imported recently. Okay? So why is it different? And I use ANN, I demonstrate that ANN model can predict perfectly the change, this change from only few parameters. And we found that primary productivity is the most important parameter explaining the change of fish biodiversity. So the high species richness in some rivers like Amazon, Congo, Mekong, okay, is not explained by the big area of this river, but also by the high productivity. The decrease of productivity due to the change of the environment, for instance, deforestation, for instance, climate change, can strongly affect the diversity of that fish. At the smaller scale, I contribute to the EU project, to several EU projects on aquatic biodiversity to predict fish abundance and diversity in the context of climate change and aquatic contaminants. For instance, the effect of pesticides on the fish population. By using machine learning, especially ensemble modeling, it is now possible to predict fish diversity in stream in the future. For instance, in year 2080, year 2100, we can predict which number of species living in such area in Europe, for instance. The results show that the fish species in our river will change a lot, and due to the climate change, in terms of species richness, turnover, and abundance. That means our son or grandson, when they will grow in different place of river in Europe, they will know the other species, the composition of species that they can see in the river, in their river. It's not the same that we know now. Just probably to my origin, during this last recent year, I had a lot of contribution for my research in China and South Asia. And in that place, the freshwater fish are very important for consumption, for human consumption. And the environmental impact in that area is very important. For example, damming, overfishing, pollution. And in China, Yangtze River, you should know, it's the third largest river in the world. It is strongly impacted by the cascade dams, especially the Three Gorges, one of the largest dams in the world, almost 200 meters high, and generate more than 20,000 megawatt of energy. It's only the biggest, according to this energy generated by this dam. My work focused mostly to preserve diversity in this river, dominated by endemic species. There are more than around 130 species living in Yangtze River. Almost half are endemic. That means if they disappear from the Yangtze River, nobody, they will disappear worldwide, and not another place can be found that species. The Mekong is international river crossing several countries, China and different countries of South Asia, and has high abundance and diversity, but Mekong is strongly impacted by overfishing and all human activity, pollution, dam, climate change. Recent research show clearly decreasing fish abundance, fish diversity, as well as fish size. That means now the fish poorer and poorer and smaller, but human is more and more human need to eat. So this is the problem. The challenge, I think, of my contribution is to preserve the diversity and the abundance of fish in this river for the future generation. So, talking something more pleasant, between Girona and Toulouse, we need only 3 hours drive. Yesterday, I left Toulouse in the morning. I give a seminar here at noon. So, it's not far. It's more or less the same distance from Toulouse to Bordeaux or Montpellier. So that means, and we don't have any border to cross, so the same. Okay, but it's much closer if you compare to Lyon. If I have to go to Lyon or Paris, I make more hesitation to do. Okay, Girona and Toulouse. Girona is in Catalonia. Toulouse is Occitania. We are very close culture each other. Okay, so I think it can be the reason why there are a lot of cooperation between Girona and Toulouse. And my cooperation with UdG is quite ancient. I met Sergi Sabater, I think he's somewhere in the room, in early 1990 in Toulouse during the PhD defense on periphyton. Periphyton is not my research area, but by chance I met him. And he told me about his colleague, namely Emily Garcia-Bertu, who is fish ecologist, that I immediately made contact. And from this date, we started our collaboration by participating in a research project and also the jury of several PhD in both sides. But the exchange is quickly expanded to the cooperation between the anti-aquaeco team in Toulouse and the anti-Institute of Aquatic Ecology team in Girona. Some example. Emily has now collaborated with several researchers in aquaeco, like Julien Couchot-Rissé, Sébastien Bros, Gaël Grenouillet, Bernard Guigny, and so on. They contribute currently to biodiversity project Odysseus that aim to study the effect of anthropogenic fragmentation on freshwater fish. Pablo Tedesco has stayed in UdG, a postdoc, in 2006-2007, and he is now IRD researcher, member of Aquaeco. I have contributed to this other member of the Institute of Aquatic Ecology in UdG. For instance, in 6th framework program, in EU 6th framework program, I contribute with Helena Guach-Padro to the Model Key project that aim to focusing on aquatic ecotoxicology. But Helena coordinates also a key bioeffect mercury project that allows us to have a joint PhD between Girona and UdG. At the 7th framework program, we got success to several Erasmus projects, Techno 1, 2, NEXI that Emily already mentioned, that allow us to host together sometime by exchange between UdG and Toulouse 3. And the candidate coming from everywhere, like Emily mentioned, China, Cambodia, Mongolia, Thailand, Vietnam, okay? And the NEXI is the bonus. The bonus because normally Erasmus fund only to cooperate with the third country. But one time they opened to have cooperation with not third country. So that means other country that in Asia, only Japan, open for Japan, Korea, and Oceania. That means New Zealand and Australia. At that time, Emily, he has some network, me, I have some network, and all together we submitted the NESI project and we got success. And these are the to say how the network can be very efficiency in the work. So at the end of 7 framework program, we moved to the Horizon 2020, and we Helena coordinate Erasmus Plus capacity building project, namely UNICAM. But with Magda, Myrnos, Frigola, and Anna Villa Gisbert, we contribute to another capacity building project, namely CONSEA. Okay, but CONSEA is coordinated by Toulouse. One coordinated by Girona, another one by Toulouse. Or we are really efficient, etc. So here only to show you that we can do very productive project together between Aquaeco in Toulouse and Institute of Aquatic Ecology in Girona. These examples show the importance of the cooperation between aquatic ecologists in Girona and Toulouse. We succeeded to create a large research network with other European universities and other countries in the world to improve the research capacity for aquatic ecology and to train the young researchers worldwide. I hope that our effort will be important for the conservation of biodiversity, especially in the aquatic ecosystems. The best honor for the university researcher, teacher or researcher like me is which come from the appreciation of the colleague in the worldwide aquatic republic. By granting me a doctorate honoris causa at your university, you have done me this honor, and my first duty is to thank the University of Girona for allowing me to receive this precious gift. I say university, but the university itself does not make such a decision. They are proposed by one or more individuals, supported by others, and finally approved and promulgated by those who represent the full authority of the university director. They are all real people and formal institution, and not formal institution. And I would like to thank all of them personally as well as collectively for what they have done to give me this honor, as well as to thank them to arranging the journey in this beautiful and historic city. It is a great pleasure and great honor to receive the degree Honoris Causa from the University of Girona. Thank you very much, University of Girona. Moltes gracias a la Universitat de Girona. Sorry, I did not talk Catalan.
estudiants, distingits doctors, presidenta del Consell Social de la Universitat de Girona, director de l'Escola de Doctorat de la Universitat de Girona, vicerectors, gerent, rector Batlle, rectora Geli, directora de l'Escola Politècnica Superior, doctor Evert Baerends, doctor Sovan Lloc and Family, director del Departament de Química, director del Departament de Ciències Ambientals, director de l'Institut de Química Computacional i Catàlisi, sponsors of the honorary doctorate recipients, friends. Universities are institutions shaped by a wide variety of historical, territorial, economic, and social factors, established actually to increase and transfer knowledge. They cannot avoid certain obligations. These include providing training that contributes to social progress and improves conditions for students, conducting research to deepen and widen our knowledge of the world and of how this knowledge influences our well-being, and being involved in sustainable development and in the struggle against inequality, and much more than that. However, there comes a precise moment in which universities, aware of all these obligations, also demonstrate what they are and what they represent, an authentic measure of their character. In one of the more solemn ceremonies celebrated during the academic year, the University of Girona does the same. By awarding honorary doctorates, the university defines and reaffirms its values, pays tribute to the individuals who have made it what it is, and recognizes their accumulated merits. Awarding honorary doctorates is proof of the university's respect and admiration, and a way of demonstrating this admiration to the world. The university is also, and to an extraordinary degree, all the persons, men and women, who have earned the most important degree awarded by our institution. The Honoris Causa doctorate ceremony is one of great significance. The university welcomes as one of its own a person or persons who have excelled in their professional and personal lives, and whose achievements have benefited the university, with which they have maintained a close, productive, and ongoing relationship. The university honorary doctorate recipients include psychologists, chemists, singers, historians, economists, philosophers, geologists, physicians, legal scholars, politicians, chefs, intellectuals, writers, ichthyologists, educators, physicists, poets, and health professionals. These men and women have, in one way or another, contributed to progress in the sciences, the humanities, and the society in general. Today, we expand this list of honorees to include 2 renowned professors recognized worldwide from the field of science. Through their work and masterful teaching, they have contributed not only to the scientific progress in the fields of chemistry and ecology, but also to the University of Girona's reputation as a leading research institution open to international collaboration. We have already drawn attention to their merits. I can only add, in the name of the university, our congratulations and our deepest and most sincere gratitude to your relevant academic work. The university's most recent Honoris Causa doctorate recipient, the poet Narcís Comadira, once said, Universities are the future of our country. With ceremonies like this, we reaffirm that purpose. It is achievable if we all work toward it. Today, with 2 new Honoris Causa doctors, we have more reasons, more hope, more support to meet the challenge. To Dr. Evert and Baerends, who, as I said, unfortunately cannot be today here with us, I'm afraid of that, and to Dr. Sovan Lloc, for whose presence I'm very grateful. Thank you very much. The university community welcomes you with enthusiasm and eager to continue our collaboration. The university is your home. La comunitat universitària us dona la benvinguda amb entusiasme, està encantada de tenir-vos al claustre de la universitat, està exultant de continuar contribuint amb la vostra col·laboració. Us homenatja, us agraeix la vostra generositat i aquesta universitat és casa vostra. Moltes gràcies. Ja estem. Moltes gràcies. Moltes gràcies al personal de la Facultat de Ciències, a tot el personal de l'àrea de comunicació i relacions institucionals per organitzar l'acte i el cor de la nostra universitat. Moltes gràcies a tots per acompanyar-nos. S'aixeca la sessió.
Ils ont oublié ça.
C'est ici.